So to formally define the attack we just saw, SQL injection says there is a query that queries the database for some data. And if the user is allowed to control part of that query, what the user can do is input something into that query that ends up being read as code. So instead of just entering words like matcha or potato, they will enter some syntax like quote or 1 equals 1. And that word or ends up being read by the SQL interpreter as actual code. So what we've basically done is we've allowed the attacker to execute their own SQL code on the web server. Now, normally, the attacker is not supposed to be able to directly access the server's database and do whatever they want. But with a SQL injection attack, you are allowing the attacker to go to the server and do whatever they want. They could leak information. They can modify the table. They could delete parts of the table or the entire table. So these are things that we don't want to happen, but SQL injection causes them to happen. So I'm not usually like a XKCD for everything kind of guy. So we're not showing you all the comics. But here's an example that maybe is kind of resonant and reminds you what SQL injection is. So here's some parent, and apparently their school is complaining to the parent. And this parent says, well, or the school says, did you really name your son Robert, quote, semicolon, drop, table students, dash, dash? And the mom says, that's little Bobby Tables. And unfortunately, when we wrote this name into the school's database, this was treated like SQL, and the school's students' database is gone. So the mom says, I hope you learn to sanitize your inputs. So that's just an example, I guess, of a undefended database where a strange student name could cause things to get deleted. And I guess if you wanted to avoid traffic tickets, you could try to drop database in your license plate, but I don't know if that works, and I don't endorse it, but you're welcome to try it. OK, so with our silly examples out of the way, one thing we should talk about is how the attacker actually comes up with the injection. So far, we've been very nice to you, and we've shown you exactly the query that you're going to inject into. We've told you it's going to be select item price from items table where name equals, quote, your input here, quote. We've told you exactly what the query is, and you can formulate your injection to match up with this query to cause malicious things to happen. Now, in reality, it's not always going to be the case that the attacker has a perfect picture of exactly what the query is. So sometimes the attacker has to guess what the query looks like and try to figure out what the injection is that causes something malicious to happen. So sometimes the threat model is such that the attacker cannot see exactly what the query is or what the table is named, and they have to make educated guesses as to what exploits will succeed. Now, another way that attackers might have their lives a little bit more difficult is that the query might not return visible feedback. So what I mean by that is, in our previous example, when the attacker said, I want to learn all of the items, the database returned all the items, and we gave the items back to the user. But sometimes the SQL query returns some records, and the code itself doesn't return all of the records back to the user. So for example, if we are using SQL to verify passwords, well, I don't know about you, but when I type in a password into the website only tells me one of two things. The password was correct or the password was wrong. The website doesn't tell me everyone's passwords. It doesn't list records that I requested, unlike the shopping example. So here's a case where even if I do manage to do some SQL injection and I ask for all the passwords to be returned, the resulting output might just say error, or it might say incorrect password, but it will not show me the list of all the passwords that the database returned. So this is sometimes called blind SQL injection, and it's blind because the attacker doesn't know what the query looks like, or they don't see what the query returns, or possibly both. And in cases like this, the attacks are a little bit more difficult, but the attacker can still make educated guesses to try and figure out what the query is, or when the query returns error, they can try and deduce what that means. And there's even automated tools to try and make blind SQL injection possible. So some examples of SQL injection tools. We're not going to use this, but if you're interested, you can go out in the real world and look up some of these tools. And the takeaway here is just that even if attacks are harder, people come up with tools to make those harder attacks more feasible.